Good afternoon, everyone, and welcome back to the final session in this room. So now my name is Patricia, and I will be introducing our speaker today. Just a couple of announcements. So if you could put your mobile phones on silent, that would be much appreciated. So please take the time now to check. Also, at 5 p.m, there will be some networking drinks in the main area. So from 5 till 6, so please feel free to network and continue the conversation. So our speaker today is Akshay Jain and from Innovate UK, and with a talk titled Data Quality for Big Data Sets. As a seasoned data engineer, Akshay has led data management initiatives and for distinguished firms such as Amazon and Visa. His expertise lies in implementing large-scale data solutions, advanced analytics, optimizing ETL processes, anomaly detection, and NLP. Akshay's effective leadership in tech restructuring migration projects has proven cost-efficient while enhancing performance across various sections. So, with a talk titled Data Quality for Big Data Sets, please welcome to the stage Akshay Jain.
Hey, thank you, everyone. Yeah. So, topic of today's presentation is proactive data quality management with the DQ and the ML library. So, in today's presentation, what I'm going to do is I'm just going to explain some of the real-time use cases that we have solved with some of the companies. What are the challenges we have faced and how we have approached that problem. So, that journey is something which I'm going to walk you through, guys, in that particular way. So first, let me just explain you, like how the general data process flow look like in most of the projects. So generally what happens is there are a certain data generations layer we have, where we have, some of the transactional sources, the data is coming from certain sources. We have a legacy data that generally go into a data acquisition layer, where we store that data in terms of some kind of data lake or data storage. On that particular data, we may apply some data transmission and the pre-processing as well. Specifically, if we are dealing with the real-time data sources or something like that. And once we have that data being stored in the data acquisition layer, it will go for a further data processing, where generally some kind of batch processing happen to put that data in a way where we can use that data for the analytics or reporting models. Sometimes we also build a ML or AI model in that particular layer as well to meet a certain business requirement. And for a consumption purposes, we create some data distribution layer on the top of it in terms of a data warehouse or data marts or something like that. So we can publish the data at the end to the reporting or analytics layer in a sense. So that's how generally the data flow look like in most of the data projects, and it grow in this particular way. Now in this particular way, some of the cases what happen is that when the data comes from a data generation process, either in the data acquisition layer or in the data processing layer, it might come with some kind of data quality issue. Or there are certain business processes where data is pretty important to them, and they basically sell the data to generate the financial revenue, and they want to ensure that in that particular process, they validate the data before they present the data or expose their data to their end consumers. So I'm going to discuss over here the two use cases where we have a similar kind of scenario, and why we get a need to implement a data quality checks over there in that way. So in the first use case, what we used to do is we used to crawl scrape around 8,000 plus websites data all over the world. So we have a mechanisms in place where we used to continuously crawl the websites data. Once the data used to get crawled, we used to scrape that data and try to identify the attributes around it. Then we used to process that data in a multiple processing layer to create a more kind of data aggregation layer, like what product coming from which company, how they are good in terms of price comparison to each other and something like that. So this activity used to happen across the 8,000 plus websites. And once we have an end result out of it, that end result is something which we used to put on the analytics layer to sell our data and to be used in a certain way. And that's how the company used to generate a revenue. Now here in this case, the challenge was that everything used to come from a crawl and a scrape as an input. So the data quality is something which is hard to deliver in that particular sense because of a certain reasons. Like for example, a company changes security layout, and due to which we cannot crawl the company pages. Or the company changes website layout on the pages, due to which, let's say, the scraper is not going to work and it is not going to scroll the data out of it. So in those cases, how to say that, that whatever data is moving from one stage to another stage, and whatever data is getting processed over there, that data is accurate or not from the reporting and analytic purposes. So it was one of the challenges that we have over there in that case. The similar kind of use case we have at a Visa, where what used to happen is in the Visa, wherever we swipe our credit or debit cards against those transactions, the data go into the data processing layer. All the data is stream data. Then it go to the processing layer. And in that processing layer, different data sets get created. On those data sets, the aggregated metrics got created. And those aggregated metrics is something which then further used to understand how the economics are doing, how the consumers' behaviors are, and all those kind of analytics and things like that. And Visa generate around 4 to 5% of its revenue out of those kind of services in that particular way. So it's a big, massive business for them, and they also want to understand and make sure that whenever this data get processed and exposed to the user, the data is get checked in a certain qualitative way, and then it is way move further in that particular sense. So these are the kind of characteristics which I have dealt with in the past, and against which we were thinking that, okay, now let's just put some kind of quality checks at each and every place, so we can say that yeah, whatever data is going is a good data in that particular way. So in this particular journey, we have, based on the experience and thing, what we have identified is that in order to solve a data quality related problems, there are 3 steps which we can take. In the first step, what we need to do is we need to perform a data profiling to understand what is the kind of data we are dealing with. Because one of the problems what used to happen is that the data which you used to get, it used to have 300 attributes, 400 attributes, and there are multiple data sets. So how we can write a general framework, and we can say that these are the things on which I want to create an alarm or alerts or something like that. So in order to do that thing, first we just need to understand that in our data set, whatever attributes we are getting, which attributes are consistent in nature, and which attributes are good to qualify for a data quality related checks. So that was the first learning that we get during this particular project, and I highly recommend that anyone starting this kind of activity, this should be the first thing that need to be identified, like what they want to validate from the qualitative perspective. The second step then come in terms of, okay, you have identified that these are the attributes which are consistent for a business. And for those attributes, now we want to implement some kind of validation. Then what kind of anomaly detections can work for them? And the third step is to set up an alarm and things on it to understand like what is the kind of threshold and things we want to use to put an alarm on it so we can reduce our false positive and we don't have too many alarms and alert over there in that particular space. So in this particular journey, we essentially come up with the same data generation flow with a data quality layer, which was primarily around the data acquisition and the data processing layer. And in that layer, the 3 activity come into a picture, which is data profiling. After that, the rule-based validation has come into a picture, because for a certain data set, it's mandatory to do some kind of rule-based validations as well, where business want to specifically validate certain domain rules before exposing a data. And the third one is where you can just use some kind of statistical techniques or time series based techniques depending on the data quality and the domain to address the data quality issues over there. So this new addition is getting added over there to process the data in this particular way. Now, when I go into this particular layer, the data profiling is something which we need to do as a first layer to identify what is important for us. In order to do that, initially what we have did is we have started with writing a Spark jobs that generate aggregated metrics and help us around those things, identifying those details. But while working on this journey, we come across this particular framework, which is called a DQ, developed at Amazon as an open source framework. And what this particular framework do is, it basically pre-calculate all the data using a Spark computation and provide us all the aggregated metrics which we required either to profile the data or to know how the data set looks like. Like for example, whatever data snapshots we are generating, if you want to identify at a data set level what is the record count, what is the uniqueness we have for a particular attribute, what are the distinct value we are having for a particular attributes, all of those things if you want to identify by using this particular DQ framework or DQ library, which is available both in Java and Python version, with the PySpark or normal Spark computation, we can just do that particular computation and we can just generate data around it, and that will basically or save over time to generate those kind of computation and things in that particular way. So like for example, if I take any particular data set, there's a test IMDb movie data set which has this particular attributes. And on this particular attributes, if I'm just going to run my DQ library analyzer, where I'm just going to say that, that whatever attribute I have in this data set, for those attributes, let's say I want to identify that what is the size or a record count of that data set, or what is the completeness of an average rating. When it says completeness, it's basically a ratio of a null to total record count kind of value, non-null to the record count kind of value. Similarly, it will identify like how many unique values are there, or what is the mean standard deviation, what is the correlation between the particular columns. So all of those things you can just identify without writing a much amount of code, and you will be able to receive a results which generally looks like this, where you will be able to see very easily like, what are the number of record it has, how many distinct value it has, what is the top rating. So by doing this kind of profiling, what you will understand is that whether your data is good for a reporting purposes or not. Like for example, you are getting a product data on a day-to-day basis, and you are generating, let's say, data snapshots on a daily basis for a certain product tables. Now on that product table, if let's say the product description is having a completeness at a 80% coverage on a day-to-day basis, or around 80% on a day-to-day basis, you can say that yeah, this particular product description is a field on which I can rely on from the data which I'm getting. But if you are getting a certain attributes for which, let's say, someday you are getting a 50%, someday you are getting a 80%, someday you are getting a 10% coverage, then you can straightforwardly say that, that these are the kind of attributes which are not reliable for the usage purposes in a reports for any kind of filtering criteria or something like that. So this data profiling basically help you to identify those kind of details on the data sets that you are generating on a day-to-day basis in terms of a snapshot. And based on that, you can just define that what attributes are important for me to use for the further, logic build purposes or to perform a analytical build purposes as I go further in that particular way. So that's how basically we have identified this thing. And after that, as a next step, what we want to do is we want to implement some kind of rule-based validations on things. That, for example, let's say whatever data we are getting in our data sets, whether that data has a certain amount of record or not, or whether the sum of the column is a primary key kind of column or not, where the value should not be a null, or value should be a unique, or the value should be 100% coverage or something like that, or the value needs to be present in a certain specific value only, like the applicable value for a priority is high or low. So if those kind of rule-based validations, if you want to implement, that also something that DQ offer in itself as a available framework, where at the time of a data publishing, you can just write this kind of rules on a particular data set, and with that particular rules, you can just validate whether that data is good to publish or not for the user consumption purposes. Because in most of the places, the data consumption purposes were more on the side where the daily data sets used to get generated, and then the decision used to be made whether we want to publish this data set for the user consumption or not, or for the external reporting consumption or not. So at the time, once you generate those data, then you can just use this kind of a framework to identify that yep, if all of these conditions or rules are getting satisfied, then maybe I want to publish that data for a further consumption, or I just want to stop that over there and I don't want to take a next action item on it and raise some kind of ticket on it to analyze it further, that why it is getting violated in a certain way. So in that way, after just doing a data generation, you can just do the data validation over here by using this kind of framework with a very minimal kind of codings or thing in place, because they all are like already been supported. The only limitation is that you need to use a Spark computation over here, either with the Python or a Scala or a Java, to use it in an effective way in that particular manner. So that's how we are, basically able to implement all the kind of domain rules over here and use to validate some of the integrity-related constraint for the attributes in a particular way before publishing a data, and we used to restrict the data in that particular way using this particular one. But one of the problem what we have, and whatever basically the results we are getting, that result is basically give us a very specific details like why it is failing. So based on that, you can just automate your ticket creations and those kind of functionalities where it can be taken to your support team and they can investigate it further to solve a particular use case. Now, we have started with this thing because our intention was not to create something like anomaly detection or some kind of things like that. Our intention was just to make a process faster so that we can release the data as it comes, and if it's good, let's just release it for the user consumption purposes. So initially we have started with like this kind of pattern, but this kind of pattern were good to a certain extent where it used to validate the data, but then we were not sure like how to check or how to basically set a trend around it, that what is a good and what is an acceptable limit versus what is a limit on which we want to stop the data and we want to keep it over there in that particular sense. So there basically the second phase come where we think now how to solve this particular problem and how to come up with details which can help us identify this data in proactive manner. And that's how basically we come and we basically go into the data science space. That is there any way where using some kind of data science algorithms or something like that, we can identify the data related issue in a proactive manner while we are publishing the data snapshot? Unfortunately, in our case, what has happened is that whatever business has started this kind of process just 2-3 years ago. And all the data that we have, that data was not qualitative to be used as a historical data as a input to some of the advanced algorithms and things like that. So we need to start with the very basic algorithms, where we have just started with the algorithms of statistical based modeling, and over a period of time, then we move further into the advanced algorithm like that. So initially, like just to give you an example, whatever snapshot we are generating for a certain data set, in that data set, we used to see that for a particular website, we are getting, let's say, 10,000 products on a daily basis. Now, if those count goes above a certain range, lower up, that is fine, because website can add a product or it can remove a product in that sense. But if those pages are going in a very dynamic range, up or down, that means there can be certain issue with the crawl process where it is not able to either crawl a data or a scrape a data or something like that. So at a website level, we have started tracking this kind of metric, that at a website level, what record count we are getting. So that record count is something which we are getting at a DQ level aggregated metric over there. And once we basically got those kind of attribute, we have started identifying that, okay, if this is what a graph look like on a day-to-day basis, how we can say that, that today's observation, whatever we have got, is good or not from the publication perspective. So in order to solve this problem, we have just initially started with a statistical method around the Gaussian distribution, where we just go and we identify that okay, if this is a daily graph, then what is the kind of rate of change we are seeing in this particular data? So when we see that particular rate of change in a data on a day-to-day basis, what we have observed is that the rate of change always, comes around the 0%, and it go in a certain range up and down in that way. Because website is going to add a product, remove a product, but if we consider a rate of change, it's always going to be around 0 in an ideal world, unless or until it's some blue moon kind of scenario where website add a very large amount of product dynamically or reduce from the website. So in this way, we have seen this particular pattern, that rate of change is something which is working for us to identify the website level changes in a certain way. And when we have put it into the Gaussian curve, we were able to see that this data has a pattern where the data is more or less kind of a normally distributed after applying this rate of change kind of transformation on the top of it. So by doing this activity, what we were able to achieve is that once we were able to publish our data sets, we were always able to check that whether whatever changes are happening on today on that aggregated count, whether that changes is lying in this particular range or not. So if it is lying in this particular range, then we are saying that, yep, it is good, now good, go ahead and publish the data. But if it's no, then go ahead and ask people in the support team raising a ticket that there can be something broken for this particular process, and the further identification is required over in that case. So while implementing this process, what we were able to do is that we were able to reach a process where around 80% of the website we were able to pass without any kind of manual validations, where it used to go as it is in that way. And around 20% of the website, we used to have a certain kind of problems which we used to highlight, and that used to go in a further way. The same is the case that has happened with the coverage related metrics, because for some of the attributes which we used to scrape in our process, sometimes what used to happen is that attributes were not able to scrape properly because of some reasons, and we want to highlight that reason on a priority because we don't want to send that attribute for a reporting purposes further. So in those cases, we have again seen that that what is the kind of coverage looks like on a day-to-day basis, and based on that, we were able to see this kind of graph over here that the coverage is varying in a certain range like this. And after that, when we have tried to identify that what is the kind of difference we see on a day over day for those particular coverage in terms of an absolute change, we are again able to see this pattern where the change generally varies around the 0% in a some range. So again, when the data get put on some kind of normal distribution curve, we were able to see that this is a kind of a range that can be worked out in this particular way. So with this kind of approach, we have started validating a data in a way. But when you started validating a data in that particular way, it has worked out for roughly around 78% of the websites, but around 22% of the website, it has started producing a result in a negative way. And out of those 22% data, whatever we used to get, around 65% of the data was a valid anomalies which we used to identify, but around 35% of the results were generating a false alarm. And that was basically become a concern for us, that even though we are doing this validation, the false alarm rate is very high, and people used to spend the work on it, and they used to come and say, that this is not generating a valid results. So that has given us some success, major success in sense of 78%, but the 22% still remain in a sense. So for that purpose, then we move to the next step, where we have run this model for a certain amount of time, did a manual validations, and we have ensured that for our websites, we are having some qualitative historical data in place. And once we have managed that historical data in place, then on the top of it, we basically move ahead with a more kind of time series based algorithm programs, where we have introduced the programs like this. Arima is the one which has worked out best for us. And in some of the cases, Hot Winkler is also producing a results. But here also we have seen a challenges that based on the domain and the website's behavior, this pattern was not very unique across the domain. So we need to do lots of segregations and the validations on it. But with this particular one, we were able to basically reach that threshold from a 78% to the 86 kind of framework in that particular way, where we were able to pass majority of the thing, but still the framework used to generate some false positives and things like that with around 22 to 23% kind of range. So in this particular way, we were basically able to improve the data quality of the product over a period of time, and we were able to resolve some of the data quality issues in this particular journey while moving further using the data quality, this DQ framework, which has worked for us to generate all the aggregated metrics and the unit testing, and then the implementation of this kind of algorithms, which has helped us out to identify this kind of data quality issues and the related thing in a proactive manner in that particular way. So, yep, this is my presentation was all about. And these are all the things which I just want to cover in this particular way. If you guys like to get in touch with me to understand a more aspect of it in terms of what kind of framework and the tech stack and the things we have implemented or things like that, then feel free to connect with me via LinkedIn or something like that. And I would be happy to get in touch with you guys to move further on that side. So thank you.
Thank you. I have a question. When you are doing all these data quality checks, there are a lot of data that get passed through this pipeline. Have you run into any kind of scalability issues? And if so, how did you resolve those?
Yeah, so scalability issues were there because our data size was very large. But at the same time, we have a Spark computation and the large cluster in place, where we have around like 600 node cluster on the EC2 infrastructure on the Amazon. So there it was fine, and apart from that, on the dataset side, we need to do a lots of fine tuning in terms of ensuring that the data is partitioned in a right way to be used in the next level. Like just to give an example, we used to have one of the data sets where the size was of 314 terabytes. And in that particular data set, the data was not partitioned in a way we want to use it. So we need to basically run a one separate process where we have first make that data partition in a way we like to, so that with a limited compute what we have, we can process that data using a Spark kind of framework. So this kind of data modeling challenges I have seen at a lot of places, because in our case what used to happen is that all the data sets were generated by the data software engineering team, and then the reporting and the visualization used to come to the data engineering team. So there was a very disconnect in terms of how data model is designed by the software engineer versus the data engineer. So that data modeling is something that we have worked a lot in between to just improve the performance of the undergoing pipeline in that sense. Yeah, but there are various techniques in which we can do the optimizations, and that very, very case-to-case basis in that way. But the general way is just ensure that your data partition is done in a correct way, so that your consumption layer and you can predict your compute over there. Also with a Spark, one of the good things is that Spark provide a library. I forgot the name of the library, but what that library do is, it basically provide you a detail that whether whatever you are running on the Spark, you are efficiently using the allocated compute or not to that program, or what is the recommendation to use a compute over there. So you can use those kind of metric also over there to optimize the thing further from the compute perspective in that way.
Thanks, really helpful.
Hey, yeah, thank you so much for the talk. And yeah, I think the question is about something that's come up in Responsible AI Hour, in the sense that as well as having these superficial checks on data, we also need to think about when data is being used. We had a previous talk about gender bias, right? Mm-hmm. And part of it is then about the data itself. So how can we include additional checks for things like representativeness to then make sure that there's a relatively equal share or equal representation of different populations in data sets?
Yeah. So I basically take these things in a two-way. So basically I divide this problem in a two-way. The first way is that whatever data you have, a person's job should be to make that data presentation as it is, irrespective of what the rules and things are there in that way. Just make that data presentable as it is, and after that define a second layer on the top of it, which basically help us identify all those kind of things and take a respective process flow around it, that how we want to reverse that, or how we want to make a more progressive changes over there in that way. So that is something we can do, because whatever data we are getting. So that's actually what has happened. Now we can just provide that thing as a feedback, and then the supportive process can be designed to handle those kind of things and consume it further in that way.
Thank you. That was a great talk, and quite vindicating, actually, because I'm in the process of building a very similar pipeline where I am. I was just going to ask you if you had any experience using Pydantic as your modeling for the Spark jobs.
Sorry, which one?
Pydantic.
No, I have
Okay, fair enough. That answers that question. Yeah, but a great talk. Thank you.
Yeah, sure.
Any other questions?
So while selecting the DQ, what other tools kind of you evaluated? Would you have kind of Atacama or the Great Expectations or any Python library would have helped? Because I mean, that also gives you a massive parallel processing.
Yeah, so when we have started this process now, this process is something that we have started in 2017. So at that time, the data quality was kind of, not that much of a buzzword as it is today. So there were very less number of people and community, and the library was working that particular point of time. But if I compare it to today there are like lots of vendors who are providing a similar kind of frameworks and things over there. So most of the frameworks and things looks very similar to what this DQ framework or things are doing. But yeah, there are numerous options available. But the only problem with those options, what happen is that in my experience, if you don't follow the process in a right way, then maybe certain framework working on a certain domain may not work on the other domain and things like that in a way. So we have seen a lots of this kind of scenario where, particularly while working at a visa, I have a prior experience of implementing this data quality framework. And then we have a couple of vendors who, because we don't want to build it again, and we want to, basically get a vendor if the product is directly available. But the same kind of challenge we are seeing, that those products and things are not coming in a way unless and until a certain processes follow to identify how we want to solve it. Otherwise, it's solved, but the ratio become very low when we calculate the return on investment on it in that sense.
Because now in the age of Gen AI, we are in the age of augmented data quality.
Yep.
If I throw a data set, it creates rule on its own. It tells me what are the rules I can create on top of the data. Rather than me writing a code, it does automatically out of the box. So like all the augmented data quality is a thing of the now and the future.
Yeah, maybe I have not explored that further on that side, but yeah, this is the way it is. Yep.
Anyone else? Okay, so let's give Akshay a lovely round of applause. Thank you very much.
Thank you.
So this concludes talks in this room, but I know there's other talks happening at 4 o'clock, and also there's drinks in the bar at 5 till 6. Now, I'd also like to say thank you for all of the volunteers, the AV team, the sponsors this year that made it all happen. And remember, the ballot is open for Oktoberfest, which happens on 19th of October. So if you go on the website, the SF website, you can put your name in for the ballot for tickets. Thank you all for attending.